You know, we're going to kind of squeeze it in there. Yeah. All right. Section 15.6, scientific notation. What is scientific notation? Well, we like shortcuts. This seems to be the chapter of shortcuts. We've learned exponent properties. We've learned product of powers, quotient of powers, power of powers. And all of those properties really give us shortcuts to simplifying expressions with exponents. So now we're going to learn a concept called scientific notation. Have you guys learned scientific notation before? Do you have any background knowledge? Okay, you started on IXL. All right. So we're talking really, really big and really, really small numbers in scientific notation. So we're going to use powers of 10 with scientific notation. So why would it be a power of 10? Well, I'm glad you asked, okay? So each place value, I want you to think about the ones place value, the tens, the hundreds, the thousands. What happens when you get up to 10 ones? What happens? It bumps the tens place up by 1, right? 10 ones is equal to 110. What about 10 tens? It's equal to 100. So what's happening is each place value represents a power of 10. All right? Back when you were in elementary school, you probably did those base 10 blocks. You guys remember the base 10 blocks to teach you place value? So that's where this power of 10 comes from. 10 is always going to be my base. So there's two forms that we're going to learn. Standard form is the expanded number in all of its glory. Okay? I can see every digit of that number. Scientific notation is a shortened way to write the same number. So I want you guys to understand, whether I'm in standard form or in scientific notation, I am not changing the value of that number. That number still has the same value. I'm just writing it a different way. You can kind of think of it like an abbreviation. What's the abbreviation for Florida? FL. FL. Okay, so do both of them mean Florida? Yes. All right, so I didn't change the name of the state. I just wrote it abbreviated. What's another abbreviation? I don't know why I'm drawing a blank. All right, North Carolina. NC. Very good. So scientific notation is a shortened way to write it. The decimal value has to be in the range of 1 to 10. We'll talk about that in just a sec. All right. So I know you guys are dying to see one of these problems.
No.
So excited. Okay, here we go. Look at the top two numbers compared to the bottom two numbers. Okay? The numbers highlighted in yellow, what do you notice about their value compared to the purple ones?
They're a whole number.
Okay? Oh, good observation. Which numbers would you rather have in your bank account?
The top.
The top ones, right? Okay? So the top numbers are what we would say really, really big numbers. All right? So there's going to be a difference in how we write these numbers in scientific notation. Couple rules for scientific notation. Initially, on a really large number, if the decimal point is not there, we know it is understood to be behind the ones place. Okay, so I need to state the obvious there. The decimal point is originally behind the ones place. So what we're doing when we write a number in scientific notation is we are shifting that decimal to a place in the number that gives me a decimal value greater than 1 and less than 10. Greater than 1 and less than 10. So my rule says to place the decimal after the leading digit, the leading non-zero digit. So if I put my decimal after the 1, is 1.73 going to fall within that range? Is it greater than 1 and less than 10? It is. Now my question is, how many place values or how many powers of 10 did I shift my decimal? So from my original decimal location to my new decimal location, I count place values, not zeros, okay? Count place values. Each place value stands for a power of 10. So let's count. 1, 2, 3, 4, 5, 6, 7, 8 place values. I moved my decimal. Okay? So each place value stands for a power of 10, which is why 10 is my base. Let's look at this next number. 25 billion. Almost as much as Elon Musk just bought Twitter for. 44 billion, okay? I should have changed it in your notes to 44 billion in honor of the news of the week.
I think he's going to be $1 billion.
Yeah, he doesn't care, but yeah.
Did you count the 7 and 3 too?
Yes, so you count place values. It doesn't matter if it's a non-zero number or if it's zero. You're counting place values, okay? But you do need to include all of the digits that are not zero in your decimal value. So that's why I have 1.73 in my decimal value. All right, so let's look at the next one. I don't see a decimal in this number. So where do I know it is understood to be? Behind which place? Behind the ones place. I want you to go ahead and write it in there. Because you have to understand when I'm writing a number in scientific notation, I am shortening that number to a decimal value greater than 1 but less than 10. So where could I move my decimal? After which number that would give me a number in that range? Where could I move my decimal value? Could I move it after the 5? Would that give me a value greater than 1 but less than 10 after the 5? No. Where do I need to move it? After the 2. After the leading digit. So now my value is 2.5. 2.5. I have a number within the range that I need. Now I'm going to multiply it by a power of 10. How am I going to know what my exponent is going to be? Place values. I didn't hear anybody say count the zeros. Don't just count the zeros. Count the place values. So I go 3, 6, 9, 10. 10 place values to my new decimal location. 2.5 times 10 to the power of 10.
So you count all the place values except for the leading one?
Right. Well, to get to the new decimal place. So I don't count the leading place value because the decimal's behind that number. I only count the place values that I'm moving the decimal point by. So I moved it 3, 6, 9, and then 10 to get it behind the 2. So that's why it's to the 10th power. All right, so now I have really tiny numbers. But I still need a decimal value greater than 1 and less than 10. So I must shift my decimal point behind my leading non-zero number. So as soon as I get to that first digit, which in this case was a 3, that's where my new decimal location needs to be. Is that number within the range that I need? Greater than 1, less than 10? So 3.2 times 10. So what's the difference? How can I tell if I'm reading this number in scientific notation that this number is actually a really tiny number? All right, so here's how I can tell. Each place value is still a power of 10. I go tenths, hundredths, thousandths, 10,000s, 100,000s. I'm going the opposite way though. So now my exponent is negative. How many place values did I move? 6. To get that new decimal behind the 3. So I moved 6 place values to the right now. So my exponent is negative. All right, any questions? Julia?
How do you decide where to put the new decimal again?
So the new decimal goes after the first non-zero digit from left to right. All right, so even with the big numbers, I go left to right. So the 1 was my first digit. I put the decimal behind the 1. All right, then I have to figure out how many places it moved.
Okay,
from
so,
the.
like you would never put it behind the 7 or the 3?
No, so you never put it behind the 7 because 17 is too big. 17 is greater than 10.
What
Never
about in front of the 1?
in front of the 1, that number is too small. It's not greater than 1.
Okay.
Okay? All right, so now on this last one, can somebody raise your hand and tell me where would your new decimal go? Where would your new decimal need to shift to? We see where it is right now, but that number is not greater than 1 but less than 10. Where would I want to put my new decimal point? Where do I want to move it? What do you guys think? Do I want to move it in front of the 5? No, that number's still going to be too small. That number's not greater than 1. What about after the 5? After the first digit that is not 0. So 5 point, I have to include all the values that are not 0. So I have to say 5.007. Because that 7's there, I have to have those zeros. I have to include all the digits that are not 0 in my decimal value.
Is the exponent always going to be negative?
When it's a tiny number, yes. Negative what? 10 to the negative, how many? How many place values did I move?
Negative
4. Negative 4. Okay, so there's some common qualities or characteristics about both these numbers. All of my decimal values are greater than 1 and less than 10. Okay? All of my numbers in scientific notation are multiplied by a power of 10. The only difference is when it's a big number, my exponent is positive, and when it's a small number, my exponent's negative. But I'm still counting place values. So, scientific notation. So now let's look at the flip side of that. Writing a number, it's going to be given to me in scientific notation. Now I want to expand it. Right? You paying attention? Okay. I want to expand it and show that number with all of its place values. First thing I want you to look at is your exponents. Which numbers, the numbers on the left or the numbers on the right, do you think are going to be really, really big numbers? Which numbers? According to the exponents. Why do you say the left?
Because the exponents are
Because they're positive. So I need to make 3.22 bigger by 5 powers of 10 or 5 place values. You understand that? Okay, so here's how I do that. I'm going to erase the highlighted. I want you to write 3.22. I want you to write it down underneath. The exponent 5 tells me I need to expand this number by 5 place values. Well, how many place values do I already have behind the decimal? 2. So how many more zeros would I need so I can expand it by 5?
3.
I need 3 more zeros. 2, 3. So here's what I need you to understand. I had some pre-algebra students say this was their answer. Well, they didn't move their decimal. They added the place values, but they forgot that when I add my place values, I'm doing that so I can move my decimal. Do you think I'm going to write my answer like this? No. Now, here's what I want you to do first. write just the digits. 322,000. Now I have my decimal. I expanded my decimal out. It's understood behind the last digit. It's not necessary for you to do the decimal after the last zero. That's not necessary. That's understood. Now go back from left to right. You must put in your comma between every third place value. You will lose points on your quiz and test if you don't put your commas. Okay? All right, look at this next number, 4. Well, I'm used to seeing a decimal value. Is 4, is that within the range of 1 to 10? Yeah. Where's my decimal if I don't see it? It's just after the 4, right? So if I need to expand it by how many decimal places? 6. How many zeros do I need? So I can expand it. I need 6. So 1, 2, 3, 4, 5, 6. Is this how you're going to write your answer?
No.
Have you done any? Technically, you haven't changed the value at all yet. 4 point, however many zeros you want to write, is the same thing as 4. Is it not? Right? What do you need to do? You got to shift your decimal out. You got to shift it out. So write all your digits, 4, 0, 0, 0, 0, 0, 0. And then what do you need to go back and put between every third place value? Commas.
So
4 million. 4 times 10 to the 6th power, I need you guys to get this, is the same exact value as 4 million. 3.22 times 10 to the 5th power is the same exact value as 322,000. It's just a shortened way to write it. Just like FL is an abbreviation for Florida. How are you guys doing with this? Brand new concept. Doing okay? So what do you think the difference is going to be with a negative exponent? Which way do you think you're going to move your decimal? To the left. Because the negative exponent says to make your number smaller by that many place values. So again, you're going to start off by writing the original number, 7.9. But now you need to move it to the left by 3 place values. So how many place values do you already have? You already have 1. If you're moving left, you already have 1. So how many more zeros do you need before the 7? 2 more zeros. Okay, so technically, my answer hasn't changed yet. I have to actually physically move that decimal. I want a 0 in the ones place as a placeholder. 0.0079. 0.0079. Do you guys see how I did that? All right, now I want you to look at this. What if I wanted to turn around and write it in scientific notation? I would move it back behind the 7, right? To write it in scientific. And how many place values did I move it? 3. -3. Do you see how I can put it right back? That's how I know I did the answer correctly. I should be able to go back and forth between these two values. Back and forth. All I'm doing is writing it in a different form. All right, look at this last number. I want you to write the original number, 8.334. So how many place values do I need to expand this number by? 6. But because it's negative, which way do I move it? To the left. So do these place values behind the decimal matter? 0.334? They don't matter because I have to move my decimal to the left by 6 place values. So my first one, my 8, does count. But how many more zeros do I need before the 8?
5.
I need 5 more zeros. I already have 1, but I have to go 6 places out. The decimal values behind the decimal don't matter because I'm not going that way. Okay? So I need 5 more zeros. 1, 2, 3, 4, 5. And now my new decimal point. So you moved your decimal point. You cannot have 2 decimals in your answer. Okay? 0.123458, 3, 3, 4. 5 zeros and then your digits. It's going to take a little bit of practice. But that's scientific notation. Just taking a big number and writing it a shortened way, or a small number, really, really small number, writing it shortened, or vice versa, going between the 2 forms. All right, I'm going to estimate. What I want you guys to do is tell me which unit would be most appropriate for the scenario you see on the right. So which unit would you measure in feet, liters, milliliters, inches, and miles? Go ahead and answer. Just draw lines. So you're just going to, however they connect. Yeah, I'm trying not to give it away. All right, go ahead and just draw lines to the matching units. What about feet? What would you say? Height of an adult. You're not going to express that in inches. I'm 65 inches tall. Do you know how many inches tall you are?
57.
57? Anybody taller than 65 inches? I'm 5'5".
68.
Okay. What about liters? What about liters, guys?
Buying soft drinks.
Buying soft drinks. What about milliliters? Mosquito. We're about to talk about a tiny insect. Not a mosquito, but another one. What about inches?
Length of an infant.
Length of an infant. Does anybody know how long they were when they were born?
7
9 or
inches.
8 inches.
No, you're not. No, you're usually about 20 inches long when you're born. 7 inches is like this.
Oh, wait a minute. It's like 15.
Okay, so like usually, normally you're like between 20 and 22 inches long. All right, what about miles?
Miles distance between Jacksonville.
All right, Jacksonville and Orlando.
1 mile.
Okay, all right. 1 female flea. Does anybody have a pet? You guys have a pet dog or cat? A pet that can have fleas? All right, so fleas are not good. They bite, they make our animals itch.
Do humans have them? No.
No, maybe lice, but I don't think
Lice is
fleas.
horrible.
Okay, so 1 female flea consumes about 1.4 times 10 to the negative 4th liters of blood per day. Okay, think about liters. What did we just say liters was an appropriate measurement?
Drinks.
For a soft drink.
No, the big
Right. So do you think that's an appropriate unit to use for
No.
female flea blood consumption?
No.
Okay, so we got this number in scientific notation. We'll deal with that in a second. A dog has 100 female fleas. That poor dog needs a flea treatment, needs a flea bath. What is the total amount of blood consumed by the fleas each day? Express your answer using more appropriate units. So obviously it's not going to be liters. We need something that matches. It wouldn't be liters, it would be milliliters,
Are you saying
right?
use
Need to be milli.
calculators for this?
You don't need it. So 1.4 times 10 to the negative 4th. In order to be able to do this conversion, I want to see this number in all of its glory. Okay? So I want to expand this number. I want you to go ahead and expand this number into standard form. Go ahead and expand this number. Now, you have to figure out which way you're expanding it. Are you moving your decimal left or right, and by how many places? way am I moving my decimal? To the left. How many zeros in front of the 1? 3 zeros, and then a 1 and a 4. So this is how much blood one flea consumes. Now I need to multiply it by how many fleas there are. How many fleas are there? 100. Okay? So you don't need a calculator for this. If I am multiplying a number by 100, no, all I'm doing is shifting my decimal to the right 2 places, because 100 is 2 powers of 10. So multiplying it by 100, I get 0.014. Okay, so this is how much blood 100 fleas are consuming in one day. All right, that would be 14 thousandths of a liter. But liter is a little much. We want milliliters. Milliliter, how many milliliters, are in 1 liter? 1,000. A centiliter, I guess, would be 100. All right, so what I'm going to do is I'm going to multiply this by 1,000. Okay, well, you don't have to do the long multiplication. How many place values did I move it when I multiplied by 100? 2. So how many place values do I move my decimal if I multiply by 1,000? 3. So now I'm just moving my decimal to the right 3 places. So this would be 14 milliliters. That's a more appropriate unit for a flea. That's still a lot. That poor dog. Okay, so if your dog has fleas, take him to the vet, get that flea treatment, and help him get rid of it. Because that's kind of miserable, right? All right, do you understand how we did that conversion? Now, maybe you're not ready to take a test on that problem, but overall, that's scientific notation in a nutshell.